Hi everybody, Miss Lorette here again with another week 2 lesson. So we're going to continue with section 8.2. This is part 2. Not a very long lesson in the sense of what we're going to be covering, but it is going to take me some time to kind of type out everything. It's a little bit harder to type out my work for these types of problems that we're going to cover today. So have patience with me if this lesson goes for a little bit as I try to type everything as clearly as possible. Just like last time, I'm going to give you a slideshow that goes along with this. It'll have different questions. Let me see if it can load up here. So this is what yours is going to look like. You're going to type in here and you're going to do all your workout. And I'm also going to upload an interactive worksheet. I'll show you what that looks like. Okay, it's going to look like this. So you'll be able to click in here and type out all your work. If you want to zoom in, just go to View, Zoom in, and it'll zoom into the worksheet a little bit easier. Okay, so you'll get your own copy. So you'll be able to type right in here as well as the slideshow. All of this will be due on Thursday. Okay, so let's just dive right in. So to begin, I encourage you to pause the video to see if you can answer this question here. It says, what is the biggest number? So I'm looking for one number that will divide evenly into each pair of numbers with no remainder. So I want to know what's the biggest number that'll divide into both 3 and 15 with no remainder. And then what is the biggest number that will divide into 2 and 12 with no remainder? And then what is the biggest number that will divide into 18 and 36 with no remainder? And what is the biggest number that will divide into 5 and 7 with no remainder? Go ahead and pause the video and see if you can try these 4 problems on your own. All right, so I'm assuming you've paused the video and you've given them a go. So here's what you should have gotten. The biggest number that'll divide evenly, and I'll change color here. Let's do purple. The biggest number that'll work here is 3. 3 is the biggest number that'll divide into 3 and 15 with no remainder. The biggest number that will divide into 2 and 12 is 2. The biggest number that will divide into 18 and 36 is going to be 18. And the biggest number that'll divide into both 5 and 7 is just 1. Okay, I can't use 5 because 5 can't go into 7. I can't use 7 because 7 can't go into 5. Okay, so what you may notice about these answers is that for the first 3, it was actually the smallest number in that pair of numbers, right? And in the last one, instead of it being the smallest number in that pair of numbers, it was something even smaller. Okay, so today's lesson is all about something called finding a GCF and then factoring it. A GCF, if you're not sure what those letters stand for, it stands for greatest common factor. Okay, so greatest, you're trying to find the biggest number possible. Common means they both have it in common. And factor is a multiplicative building block, okay? So for example, if I look at the number 3, 3 is a factor of 3 and 15. You can multiply 3 with 1 to get 3 as your answer. You can multiply 3 with 5 to get 15 as an answer. It is a multiplicative building block of both of these numbers. In other words, it is a factor. Okay, so that's what greatest common factor stands for, and that's what this lesson's all about. And your hint for how to find the greatest common factor is kind of what we noticed in that previous slide. Your GCF is always going to be equal to or smaller than the smallest of those numbers. And that seems a little counterintuitive when students first come across this because they see the word greatest and they think, well, if I look at this pair of numbers, it's got to be the biggest one, right? Because greatest common factor, it's the biggest. Well, it's actually the opposite. Greatest common factor, this is actually the biggest number that will work. It's the smallest of the 2, but it's the biggest one that will divide evenly into each number. Okay, so it's a little counterintuitive. You're going to choose the smallest number within that pair, or it's going to be something even smaller if the smallest one doesn't work. So my suggestion to students when they're first learning how to determine what a GCF is, I tell them, look at the numbers and check the smallest number first. If the smallest number can divide evenly into every single number that you're looking at, that's your GCF. If it doesn't, it's got to be something smaller than that. Okay, like in this case down here, 5 wasn't going to work. It wasn't going to divide evenly into 7, so it had to be something smaller than that. All right, so a few more tips. So your greatest common factor. If all of the numbers within a group are prime, then your GCF will be 1. So let me go back to that slide again, okay? And you may want to do some review on what a prime number is. So in this first group of numbers, 3 is prime, but 15 is not, okay? So my GCF, I was able to determine that it was this number right here. 2 is prime, 12 is not. My GCF ended up being the smallest number here. 18 is not prime and 36 is not prime. My GCF ended up being this number right here. It won't always be the smallest number, but if you're looking at a group of values and all of the values are prime, the greatest common factor is going to be 1. Okay? If it's not, if they're not all prime, then it might be something greater than 1. All right, so let's dive into some examples. So for the slides that you're going to complete, I'm going to give you a polynomial, and I'm going to ask you, what is the greatest common factor for all of those terms? In other words, I want to know what's the monomial that can divide evenly into this and this. So I've listed some strategies on how to approach this problem, and I'm going to do a couple like this with you. Strategy says, number 1, list all of the prime factors for each term. So I'm going to just write my terms here. For a text superscript, I encourage you to try and figure out what the keyboard shortcuts are for superscript on your computer. I'm going to do it the old-fashioned way so you can see where I'm going. I do know what the keyboard shortcut is, but I'm not going to use that. So here's term number 1, and I've got a positive 6a squared. Here's term number 2. So step 1 says list all the prime factors of each term. Okay, so my prime factors are going to be 2 times 2. That's going to give me the coefficient of 4. And then to get my a to the power 4, I just expand it into multiplication. That means I've got 4 of them. I'm just using these asterisks to represent multiplication. Hopefully that's clear. There is a multiplication dot, but it's just not going to be worth the time to insert it. You have to go to insert, special characters. You have to find the symbol. It's not worth the time. Okay, so I've broken this term down into all of its prime factors. I'm going to do the same thing here. Okay, so the prime factors for 6, the coefficient, is going to be 2 times 3. Those are my prime factors that give me 6. And then a squared, I'm just going to expand it into multiplication. I've got 2 of them based off of what the exponent's telling me. Okay, so step 1 is done. The next thing I want to do is identify the factors that are common to each term. Well, if you notice, each of them have a 2. I've got a 2 right here. Let me highlight. I've got a 2 right here. And I've got a 2 right here. I have another 2, but I don't have another 2 in my other term. They're not common, okay? So when you're looking for the factors that are common to each term, you want the same number and you want it to appear the same number of times. So I have a 2 here and a 2 here. Let me make this a lighter color. It's kind of hard to see. Let's do this one. And we're going to do this one. Is that the same color? Yeah. Okay, so that's the only thing that's common in terms of the coefficient. Now let's see what variables are common. Well, obviously they have a bunch of a's in common, but remember, it's got to be the same number of times as well. So I know that I have an a that's common right here, and an a that's common right here. I have another A that's common with an A that's common right here. Okay, so I've got a 2, an A, and an A. So I've listed all of my common terms. In order to get your GCF, you're going to put all those common terms together. So I've got a 2, an A. Let me actually highlight what's matching here. So here's the 2, an A, and then this A right here. And notice I'm only listing it once. One copy for each common term. A 2, an A, and an A. And then to get my final answer for what that GCF equals, you just multiply them all together. 2 times A is 2A squared. Here's my GCF. Okay, that's my final answer, 2A squared. So the thing that's going to be the greatest common factor is a 2A squared. I could divide this term by 2A squared and not have any remainders. I could divide this term by 2A squared and not have any remainders. Okay, so to recap what I just did here, because it's a little confusing if you haven't done anything like this before. I took each of these terms inside this polynomial and I broke it down into all of its prime factors by just expanding it into multiplication. I did the same thing for the other term. And then I identified the factors that were common to each one. They each had a 2 that was common, and then they also had 2 A's that were common. Anything else that was left over that didn't have a matching pair did not get listed as part of my GCF. Okay, I only took one copy of each thing that was common. So I had a 2 that was common, I had this A that was common, and I had a second A that was common. I multiplied it all together, and that was my GCF. Let's do another one like this. Here's my polynomial. 5x cubed plus 25x squared plus 45x. I'm going to do the same thing. I may even make my font a little smaller so I've got a little more space to type stuff out. So I've got 5x cubed that I'm going to want to write it as the product of its prime factors. I've got a positive 25x squared that I'm going to want to write as the product of its prime factors, and a 45x. So I'm just going to break this down into all of its prime factors. Well, 5 is prime. That's my coefficient. And then I just expand how many x's I have. I have 1, 2, 3. That's what that exponent tells me. 25, I can break that number down into the product of 5 and 5. And then x squared just means x times x. 45, I can break down into 5 times 9, and then times x. And now I want to identify all the factors that are common. And again, it has to appear the same number of times. So even if it's common, like let's go back up here. Even if this had a 2 and then this had a 2, I was only able to match one copy. Okay, so this has to have a pair. Okay, this 2 matched with this 2, and then this 2 was left over with no matching pair. So same idea here. I want to find something that's common across all 3. Well, I see that each one has a 5. So I'm going to start by identifying that. Here's a 5, which matches with this 5, which also matches with this 5. I don't have any more 5s here. I do have one here, but because I don't have another one here or here, I can't use this one to match up with anything. Okay, so it's like a matching game. However many terms you have, that's however many common factors you need to make a group. All right, so now let's see how many x's can I combine, or not combine, but match up. I have an x here, an x here, and an x here. So I'm going to say this is blue, blue, and blue. All right, so I know that I've got an x that I can match across all three. I still have two x's left over, an x here, but no x here. So I don't have any other groups that I can put together as a trio, right? I don't have enough x's in this last term and the second term to match up with anything else. And then let's take a look at what we're left with. I still have a 5 here. It doesn't have anything it can match up with. And I have a 9 here that doesn't match up with anything. So I've identified everything that's going to be common across all three terms, a 5 and an x. And that's it. That's the only thing that I can put together here. So my GCF, if I put those terms together, here's my 5. Oops, too dark. And then I put that together with the x. I'm just trying to color code things so you guys can really see here. I know it takes a second, but I just want to show you. You don't have to color code stuff like this when you're doing your work. I'm just trying to do it to make sure that it's very clear where I'm getting these values from. Okay, so my GCF is just going to be the terms that are common, and I just multiply them together to give me 5x. There's my GCF. Okay, that's the biggest thing that I can pull out of all three of these terms, where if I were to divide them, there would be no remainder. I could divide 5x cubed by 5x and not have any remainder. I could divide 25x squared by 5x and not have a remainder. Same thing here. I could divide 45x by 5x and not have a remainder. Okay, so there's my GCF. Now for the real meat and potatoes of this lesson. And factoring is such an important concept in honors algebra. Okay, when you guys move on to your math classes for the future years, factoring is so important. Okay, you need to know how to factor moving forward in math. What I'm going to do is I'm going to show you how to do it by listing all the work here. But the idea is that once you're out of 9th grade and you're in a class where you have to do this, you can do it in your head without having to show all of this work. Okay, so as I mentioned, it's going to take a little bit of time for me to type all of this out, and it's going to look like a lot of work, but the idea is that you're going to get so good at factoring that you're not going to have to list all of this work. You'll be able to do it in your head, okay? So when you are factoring a polynomial, you're going to start by doing what we did here. You're going to find what the greatest common factor is for all of the terms, and then you're going to factor it out of each of these terms. It's kind of like the opposite of the distributive property, okay? So basically, we're going to go from something that looks like this to something that looks like this, where you've got a number and some variables on the outside of a set of parentheses with all of the remaining terms on the inside. So it's going to look something like that. It's basically the opposite of the distributive property, okay? So here's what I'm going to do. And I don't know why I didn't think of this before, but I'm going to copy paste. Copy. Copy. I just want to look at the 24x. I don't care about the negative. So basically all I'm doing to start off with is what I did last time. I'm taking all of these terms and I'm setting them up so I can list out all of my prime factors. So 4x to the power 5, well, that's going to be 2 times 2 times 5 individual x's. 1, 2, 3, 4, 5. 24x, I can list that as 2 times 2 times 3. That's right, right? Nope, that's not right. 2 times 12. 12 is going to be 2 times 6, so I need another 2. So let's double check that. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is definitely 24. Okay, so you may want to do that out on a piece of paper if you're struggling to do it in your head. And then I have 3 individual x's. There we go. 8x, I can break that down as 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And then just one x by itself. Now, step 2, find the GCF. Okay. Well, my GCF is going to be the terms that all of these have in common. I have a 2 here, a 2 here, and a 2 here. So let's see. I'm going to do purple. Here's its matching pair, and another matching 2. I have another 2 here, another 2, and another 2. So I can actually pull another 2. I should probably choose a different color. It looks a little too similar. Let's do green, green, green. See how there's another one that I can take out? And then that looks like that's it for my coefficient. I don't have any other coefficients in this factored form here. I do have a few more coefficients, but if there's nothing left here, nothing else is going to match up. Even if I have some remaining in this one and in this one, there's nothing left in this first one. So I can take out a 2, and I can take out another 2. That's as much as I can take out. Now let's see how many x's I can take out. So now I'm going to have to multiply with some x's here. I have 1 here. Let's make this color. I have 1 here. And I have 1. I think I made that too dark. I just want it to be color-coded so we can really see. Okay, so I have 1 here, 1 here, and 1 here. There are no more x's down here. So even though there's x's remaining in this second and this first one, it's not going to match up with anything in this third. So I can only take out the 1x. Okay, I can only take out this one singular x. So my GCF is, when I multiply it all back together, is going to be 4x. That's my GCF. Okay, so far, all I've done is what I did in these previous slides, where I found the greatest common factor. Here's where factoring actually happens. You're going to take that greatest common factor and put it outside of a set of parentheses. What goes in the parentheses is what you're left with when you divide each of these terms by the greatest common factor. Okay? So if I divide 4x to the power 5 by 4x, let's do it piece by piece. If I divide the coefficient 4 by 4, I'm left with 1. Okay, 4 divided by 4 gives me 1. Here's where it starts to get a little more complicated, because you guys are probably not used to dividing variables by variables. Think properties of exponents. If you divided, okay, let me do it off to the side here. If you divided x to the power 5 divided by x, what would you do with those exponents? What was that property that we learned in chapter 7? Okay, remember, this has an exponent of 1 on it. Well, you would subtract. You'd subtract the exponents. Okay, so what you're going to be left with is an x to the power 4. Yes, I just used my keyboard shortcut because I want to try and get through this explanation a little quickly. So if I divide this x to the power 5 by this x to the power 1, you're going to be left with an x to the power 4. You're using properties of exponents here. Okay. Let's do the next term. If I divide negative 24 by 4, that's going to give me, I hate how it keeps doing that, a negative 6. That's my coefficient piece. All I did is I divided. Negative 24 divided by 4 gives me negative 6. To figure out what my x will be, I'm going to take the x to the power 3 and I'm going to divide it by this x. And again, it's to the power 1. So what do you do with those exponents? You subtract them. So you're going to get x to the power 2. So in this quotient here, which is what this really is, because you're dividing, you're going to get an x to the power 2. Okay? And if you're unsure if you're getting the right answer here, multiply them to see what you end up getting, okay? I can show you that after I get my final term here. So 8, I'm going to divide that by 4. That's going to give me a positive 2. And then this one hopefully should be easy. X divided by x just gives you 1. So there are no more x's left. In other words, if I were to do it like I did here, x to the power 1 divided by x to the power 1, well, that's going to give me an x to the power 0. X to the power 0 is just 1. I don't have to write 2 times 1. Okay, we want to simplify that and just write it as 2. And then I close my parentheses. So as I mentioned before, when you take out a GCF, it's like the opposite of the distributive property. We went from something that had no parentheses to something that had a term on the outside of a set of parentheses. And if you're unsure if you're getting the right answer, you can go back and multiply to see if you get the original question. 4x times x to the power 4, add these exponents, you should get 4x to the power 5. 4x times negative 6x squared, 4 times negative 6 gives me the negative 24, x times x squared gives me the x cubed. 4 times 2 gives me 8, and x times an understood 1 gives me x, so I get 8x. Okay, so to recap what we just did, I broke down each individual term into its prime factors. I identified what was common across those prime factors to find my GCF. I pulled the GCF out of this polynomial and divided to see what was left inside the set of parentheses. Okay, let's do another one like this. And I have not one more, but 2 more because I want to really have us practice this. So I'm going to take each of these terms and I'm just going to copy paste to save time. Whoops. And I'm going to write all of them as the product of its prime factors so I can find my GCF. This piece here, I'm going to go back to the slide, this piece here for finding the GCF is eventually what you'll become good at doing in your head, finding what the greatest common factor is, okay? And also doing this part here to where you won't have to do all this work to the side. In fact, you don't have to show me this part when you do the you try slides. I'm just doing it so you can see how I'm getting my terms. Okay, so let's see if we can do this one quicker. 4x cubed, that's going to be 2 times x times x times x. 8x squared, that's going to be 2 times 2 times 2 times x. 12x squared, that's going to be 2 times 12, which is 2 times 3. Wait, 2 times 2 times 3. So let me double check that. 2 times 2 is 4. Nope, that's not right, Kim. 2 times 2 is 4. 4 times 3 is 12. There we go. There are my prime factors. And then times x. All right, so here's what's common. A 2, whoops, and a 2. This would be so much easier if I wasn't typing it all out. I see another 2. That's common. Another 2. And another 2. And then that's as much as I can take from my coefficient. I don't have any more coefficients to pull from here. I do from the last 2, but if it's not going to have anything to match up with in the first, then that's it. I have an x and an x. Whoops. And another x. And that's as many x's as I can pull because this last one doesn't have any more. Okay, there's more in the first and the second, but there's no more in the third, so I can't take what I don't have. So my GCF is going to be 2 times 2 times x, which in this case is 4x. And then I'm going to take that 4x and I'm going to stick it on the outside of a set of parentheses. To figure out what goes inside, I'm going to take all these individual terms and divide it by 4x. Well, 4 divided by 4 is just going to give me 1. X cubed divided by x is going to give me x squared. Okay, I'm just using properties of exponents and subtracting here. 8 divided by 4 is going to give me 2. X squared divided by x is just going to give me x. Okay. 12 divided by 4 is going to give me 3. X divided by x, they cancel out. I'm left with 1, so I don't put anything there. I don't put the times 1, and it's not times x, right? If I did x divided by x, like in this last slide, look what happens. You get an exponent of 0. Anything to the power 0 is just going to be 1. There are no more x's on this last term. It is just 3. Here's what I'm left with on the inside, and if you're not sure if you got it right, multiply to see if you match the original question. 4x times 1x squared gives me 4x cubed. If I add those exponents together, I get a cube. 4x times 2x, 4 times 2 gives me the 8, x times x gives me x squared. 4x times 3 is going to give me 12x, so it works. That is my final answer, and this is what it means to write something in factored form. Okay, let's do one more. I'm going to take all of these terms, quite a long polynomial this time. No, don't capitalize it. 24g cubed, 12g squared, 4g. And turn off the superscript. Stop capitalizing. There we go. So g to the power 4 is just g times g times g times g. 4 of them. Whoops. 24g cubed, that's going to be 2 times 12. 12 is going to be 2 times 6, which is 2 times 3. So let's see if I did that correctly this time. 2 times 2 is 4, times 2 is 8, times 3 is 24. And then g to the power 3. 1, 2, 3. 12g, 2 times 2 times 3. Oops. And then g squared, g times g. 4g is 2 times 2 times g. My GCF is going to be what's common. I see that they all have a 2 in common, another 2, and then that's it for my coefficients. I've got 2 times 2, 2 times 2, 2 times 2. No more coefficients in this last one. So even though there's more coefficients in the first and the second, I can't take what I don't have. So now I check to see how many g's I can take. Well, I only have 1 in this bottom one, so it's only going to match up with a g here and a g here. So even though there's more g's left over in the other terms, I can't take what I don't have. I can only match what's common, which in this case is going to be one of those g's. So my GCF is going to be 4g. I take the 4g and I stick it on the outside of a set of parentheses. And then to get what's left, I simply, wait a second. Oh, I messed up. I forgot about this term up here. Ooh, that's not good. Okay, so that's not my GCF. That's okay. This shows what you do when you start messing up. Here's how I caught that I was making a mistake. Watch. When I started typing this out and I said, okay, well, if I divide this by my GCF and I said, hold your horses, I can't divide this by 4. I must be making a mistake here. So let me go back. I forgot that we have more terms in this one. So let me go back and fix this. Look at this top term. I don't have any coefficients, so I actually can't pull out a 2. These all have 2's in common, but this doesn't. So my GCF actually isn't going to have a coefficient at all. It's only going to be this term. Let me highlight that. That's the only thing it has in common. Would have been much easier doing this in a classroom. I bet you a student would have caught this. So look, that's all I can take out. This doesn't have a coefficient, so I have to take that out. My GCF is just going to be G. Well, that's actually going to make the dividing a lot easier, so that's good. So if I divide G to the power 4 by G, I'm just going to get G to the power 3. If I divide 24 G cubed by G, the 24 is still there, right? 24 divided by 1 is just 24, and all I can do is simplify how many G's I have left inside. That's just going to be G squared. 12 divided by 1 is just 12. All I can do is simplify how many G's I have left. G squared divided by G is just G. I'm just subtracting the exponents. 2 minus 1 gives me 1. And then 4 divided by 1 is just 4. G divided by G is just 1. So I don't include the G. Okay? And again, you can multiply all these out to see if you match. Here's my final answer, which is now correct. Okay? Okay, so a little bit complicated if you've never done this before, but take your time. Look at how I've color-coded things. You don't have to color-code your work, but I tried to do that so it was easy to see what I was doing. Our homework is going to be the You Try slides. And what I'm going to give you, it's going to be similar to what I did. It's just going to be different problems, as well as that interactive worksheet. Okay, give them a go. Let's say it's due Thursday, the 9th. If we're really struggling with this, because this is new, we'll revisit this and do more of this stuff the week that we're back from spring break. Okay, good luck with all of this. As is usual, let me know if you have any questions. Take care.